With that, we are now ready for the main presentation. Our presentation today is Seeing the Quantum Horizon, Hype, Hopes, Hybrid Systems, and the Road to Quantum Advantage and Value. And I'm very pleased to have three, not only quantum computing experts, but three friends, Sebastian Hassinger, Bob Sorensen, and Worley. Thanks for joining us on the session today, guys.
Thanks for having us, Jay.
Thanks, Jay.
Cool. Glad to be here.
All right. Is everybody's camera on? It looks like it. Great. All right. So I'm going to ask you guys just to give a really quick introduction to yourselves and your place in the quantum computing ecosystem before I start with a handful of questions that I've sort of seeded with you ahead of time. But let's start with a real quick intro to your place and role in the quantum ecosystem. Worley, why don't we start with you? Worley, you're on mute.
Well, that would help. I said, I'm Worley. I'm founder and CEO of StrangeWorks, and we provide really advanced optimization based around quantum-inspired things, as well as connectivity to a large variety of quantum computers so that people can use them and access them and fit them into their business easier.
Bob.
Yeah, Bob Sorensen. I'm the Chief Quantum Computing Analyst at consulting company Hyperion Research. Look at quantum primarily from the HPC perspective. What are the HPC end users interested in? What does quantum bring to the table for them? And that's really how we got involved in examining quantum for about the last 8 or 9 years now. It's HPC end users with the tough questions. What does it mean to me? What can I do? And what can it do better than I've never been able to do before with quantum? And that's pretty much our goals, trying to figure out how quantum applies to the advanced computing ecosystem as another tool in the toolbox.
Great. And Sebastian.
Yeah, Sebastian Hassinger. Hi, everybody. Independent consultant, podcaster, author, entrepreneur. I joined IBM Quantum in 2018 and then spent a number of years at AWS from 2021 until January. Now I'm independent. So working on a couple of stealth projects, working with the Unitary Foundation and appearing on this event. So very excited.
Okay, and Worley and Sebastian, it is totally okay to plug a book or a podcast or something. Worley?
I mean, I've got, of course, the ever popular Quantum Computing for Babies, which is available on Amazon, but also Quantum Computing for Dummies. But I wouldn't buy that one right now because the second edition is due out here in a couple months. So it'll be greatly expanded and updated. That book's probably about 3 years old now, I think.
All right, look forward to that. And Sebastian.
Cool. Yeah, the New Quantum Era is a weekly podcast. I talk to researchers, entrepreneurs, product people, and public sector sort of ecosystem owners. And I've been doing that for 3 or 4 years now, just over 100 episodes. And I just published a book in May called also The New Quantum Era, because apparently I don't have much of an imagination for titles. That's an overview and an introduction for people who are not physicists. So it goes from sort of the, an overview of quantum physics itself, classical information theory, and then the convergence of the two, and talks about the sort of leading modalities and the current status of the industry.
And that is a great lead in to my first question on leading modalities. We have a set of questions about the current quantum landscape, but I wanted to get a fundamental question out of the way first. Unlike classical computing, where there's essentially one modality, there are a half dozen popular modalities in quantum computing, and then more beyond that even. How are you seeing progress among these different modalities? And you can name vendors if you want or not, however you feel comfortable. You can talk about where we are in the journey so far, but everybody always wants to know, which modalities look promising. And Bob, I always go back to something you said in a previous episode. You really love the quantum computing community for two main reasons. One, they're also incredibly passionate about quantum computing, even though they're all doing it in different ways. And two, we all believe that only their way will work. So I'm going to start with you and see if that's still your assessment of the quantum computing community. And I'd love to hear from each of you how you see the various modalities progressing.
Well, first, let me just jump in, Jay, because you said, it's not like silicon where there were one modality. There wasn't one modality. We started out with tubes, then we moved to transistors, then we moved to integrated circuits. And even within that, do we use gallium arsenide? And even when we finally fixed on silicon, do we use a heterojunction bipolar transistors? Do we use CMOS? And it took years and years for all of the dust to settle here. So I'm not looking for a modality to rise to the top very quickly. The one point I will make, though, is I'm starting to shift towards how I basically evaluate modalities based on some interesting specifics. One of the things I'm seeing lately is a lot of interest in low density parity check error correction codes versus surface codes, and certain modalities are much more amenable to that. So there's maybe some advantages looking at that perspective. The issue of scalability, which modalities offer 1 million qubits on a chip versus the ability to build a modular multiprocessor quantum system. So to me, I'm looking at modality advantages more from the architectural standpoint increasingly than I am from saying, okay, this guy's T1 time is better than that guy's T2 time and those kinds of things. It's really start to look at not the modality, but the kind of quantum computing architecture that that modality engenders.
Great point. Sebastian, you want to go next?
Yeah, I mean, I agree with Bob. I don't think there's going to be convergence in the near term, and I agree that if you look back at the history of classical computing, we saw a very similar kind of evolution, and even now, like there's discussion about sort of creative ways to get past the extreme UV kind of the performance limitations, right? We're hitting it up against the ceiling of it in a lot of ways. So I agree. I tend to think in terms of also near, mid, and long-term sort of success. My feeling is that right now we're seeing a lot of action in atom-based qubits, neutral atoms, and trapped ions. They're very high fidelity, but they're very, very slow. They got good connectivity as well. You can do all-to-all. But I think that in the near term, we're going to see, Oratomic, for example, is now sort of very ambitiously trying to build a machine in the next, I think they're saying 3 to 5 years, typical time frame, that'll break RSA 2048 using Shor's. That's a neutral atom device. But then in the midterm, I think the performance issues are going to start to really limit the effectiveness or the use cases that they can address. And superconducting qubits are most likely in the midterm to sort of break those barriers. Is much faster. There's issues around scale and connectivity that they're trying to address right now, and error correction, as Bob said. QLDPC is sort of being applied in the superconducting regime, but then I think there's scale issues with at least the way superconducting devices are being designed today. And eventually, I mean, the holy grail is most likely spin qubits or potentially photonic, because you can sort of see the clear path to scalability with both of those modalities, although there's significant sort of scientific and engineering hurdles that are going to take longer to resolve with those modalities. So that's kind of the way I see the road ahead.
Really, you want to wrap this question up?
Sure. I mean, look, I love what both Bob and Sebastian said, especially what Bob said about bits. Everybody seems to just think, forget all the history of all of the different modalities and things we had to go through there. So I thought that was key on. And Sebastian makes some great points too. I think the thing to start with is a qubit is not a unit of business value, right? The advantage is a property of some in workflow that some business is doing. And so when I think about all of these different modalities, I look at it and I say, look, the science is advancing, the engineering is improving, but the business value is still emerging, right? And it hasn't really arrived broadly. So I looked at things that are closer as far as modalities to what we use now. So if you look at some of the silicon spin technologies, if you look at some of the things like what Nick Farina is doing at AeroQ, where they are CMOS compatible and their error correction is compatible as well, as maybe not the overall winner long term, but what gets us to the business value short term, in that it can be produced in any fab. It doesn't need a special quantum fab or special error corrections and things of that nature. Because I think we're still struggling with, there's going to be a few modalities for a while. We're in the very early stages of that, even though, as Bob said, I mean, we met, 8 or 9 years ago. Sebastian and I have known each other like 30 years, and he went to work at IBM Quantum. I was starting StrangeWorks, so I think things are starting to pick up the pace and moving faster, but I look at the modalities that are closer to the things that we use today, because I think at the end of the day, it's going to be the economics that creates it. It's going to be the beta versus VHS, which Sebastian and I have said on stage 1,000 times together. You can make the perfect qubit, but be the Betamax. But VHS, if it's affordable and deployable and people can take advantage of it, their business is going to win. So for me right now, really taking a big interest in all of the things that are closer to CMOS, and less, we got to build a whole new fab and do a lot of new science. Although a lot of those are great technologies too.
Just for our audience, not all of whom are probably familiar, can you share which modalities leverage CMOS technologies in their modalities?
So the helium electron stuff, the silicon spin, there's a few others, but those are the two I'm paying attention to.
Great. And
it's also worth mentioning that John Martinez is working, his company Colab is trying to, with Applied, trying to leverage the CMOS process in a superconducting regime. So there's significant hurdles, but they're working on it.
Now, each of you started into your answers related to my next question. So I'm going to ask it more explicitly, which is, how do you define meaning in these systems? So Bob, you talked about it as an architectural approach as opposed to a type or number of qubits. Worley, you talked about it as how it's going to map to a business problem. Can each of you speak just a little bit more on how you would measure progress in quantum systems today? If not qubit counts, are there benchmarks? Are there metrics? How would you measure progress for a company today? If you had your own company and you weren't just trying to put out press releases to get your Series C funding, how would you personally measure progress of your own architecture? Worley, let's start with you on this.
I mean, for me, look, I've moved over the last 10 years in this, mess around this space, in the last 8 years at StrangeWorks, into this total lens of economics. Right? It doesn't matter if it's 1,000,000 times as fast, if it costs 100 times as much, right? No CIO is gonna deploy it. And so when I look at that, I look at, look, we're starting to solve the coherence times, right? They're getting longer. We're starting to get, qubits more stable. We're starting to get more qubits. All of this is great. But again, it has to have the rubber meet the road to a CIO or CTO who probably is never going to understand the technology and is probably of an attitude that's like better, faster, cheaper, right? And so I look at it, right now, this year, I've been really focused on just the economic lens, which is, what would I measure? I would measure the cost of using the quantum machine compared to the cost of my alternatives first. I would then look at performance, right? Because I'm not even going to go and run a performance test if it's going to cost me $3,000 an hour over here and 16 cents, on a Google's cloud for a GPU over here or whatever. So, I mean, I'm really looking at it from that economic standpoint. I think the performance stuff is, a lot of it is demonstrably rigged. Everybody has their own solver. They make a super hyper custom solver. They compare it to a classical off-the-shelf solver. Like we all know these games. This is not new the quantum didn't invent this. It's not new or exclusive to quantum. But I don't think that there's a lot of technical measures that I, as a CEO or CTO, could rely on to say, okay, I'm looking at these things objectively, which leads me more again to let's talk about what it costs first, and let's talk about what I get for that cost, and then let's talk about what the return on investment of spending that cost is.
All right, Bob, Sebastian, anything to add to that? How would you measure the success of, say, your own company in progress and making a quantum system that you hope to have real value?
Yeah, I mean, I agree. The economic lens is critical for the industry as a whole. For the technology, though, I mean, the measure of progress is how close are we getting to a quantum computer being able to do something that a classical computer just cannot do. Not the intractable problem kind of scope of things, right? And that's why there's so much attention to sort of the benchmark of Shor's and RSA 2048 or whatever, because that's, the security of that relies on it being classically intractable to factor to its primes. And the promise of Shor's is that a quantum computer of sufficient scale will be able to do that in a reasonable amount of time. I think Shor's is one benchmark. I think more broadly, though, just many body system simulation, right? I mean, going back to Feynman in 81, the justification for quantum computers was, if you want to simulate nature, you have to do many body simulations. They're really, really difficult, and past a certain scale, they're intractable. I talked to Steve Gervin at Yale about a year ago and asked him if he thought of his work as building a technology or building a science instrument, and he said absolutely science instrument. So I think that is a really tangible, the scale of the many body system that can be simulated, which we're getting really close to doing simulations that just can't be done classically. I think that is a really great measure to, of the progress of the technology itself, whereas what we're really talking about is more the industry progress.
But just to chime in right quick before Bob goes, but Sebastian, I've read like 10 press releases that everything you just said has already happened, including from former or IBM this month. So how do we discern through all of that?
Yeah, I mean, and in fairness, I think there's always a kernel of truth in those claims, right? I mean, no one's just straight up lying. It's just, there's everything from a contrived problem with a random circuit simulator or a sampling kind of supremacy experiment, which that's something that's designed to be hard or impossible to do classically, to things that are on the margin of, you kind of sort of have to squint your eyes a little bit to say that's not possible classically, or there's a clear quantum advantage. I would say, okay, so going back to the roots of classical computing, right? Those machines were built to accelerate physics calculations and other sort of mathematical tasks. And I think, there was a pretty clear point at which, the systems were able to sustain calculations that just weren't possible by a room full of people with pens and paper. And I think we'll know when we know. Basically, it'll be really obvious when it's like, oh, that's impressive, and there's no way we could have possibly done it. I think that's why Shor's attracts so much attention, because it is so plainly an intractable problem. That's what the whole RSA and other encryption technologies are based on, it being an intractability, the intractability of it. So, but in science, I think there are all kinds of, direct simulation of quantum systems at a scale that we know we just can't do classically. And that's what I look at.
Bob, you want to close this one out?
Yeah, definitely. To me, you got it. The end user perspective, demonstrated performance gains on workloads that matter. And the performance gain, I think, is arbitrary. I understand the hype of classically intractable. I understand the hype of quantum superiority, but I sincerely doubt if I went to a quantum chemist or a computational chemist and said, sorry, I can't give you quantum superiority, but I can give you 100x performance improvement over your existing $600 million HPC, $25 million. They're going to go, I'm going to wait. Because I'm real excited about Shor's algorithm. I think that the end users are interested in basically accessing value that gives them a leg up competitively, whether it be by driving innovation or economic advantage and such. Some of the examples that I really like, IBM did some work with a financial house, and they just figured out a way to get a 30% performance improvement on some pricing of options going onto the market. 30% performance improvement on an application that scales across billions of dollars, 24/7, 365 days a year. That's nothing to sneeze at. No one should stand back from that and say, I'm waiting for demonstrated quantum superiority. And to me, that's the key here. The one thing I want to jump in on, Jay, I'm going to wander a little bit.
I know you are, Bob.
You mentioned the word benchmarks. I am not a huge fan of benchmarks right now, because the wrong benchmarks can set the sector on the wrong trajectory. And I will point out LINPACK, the idea that for the last 40 years, everyone said the way to measure a classical computer is its ability to solve a series of linear equations that doesn't require access to memory or storage. And we belabored under that's what made a machine effective, and that's how we valued them. My worst fear in life, and I will probably climb to the top of a tall building if it happens, if I ever see something called QLINPACK, where again there is a standard benchmark that may or may not point the sector in the trajectory where it needs to go, and will create a false impression of what matters and what doesn't. So benchmarks are interesting, they're compelling, they're kind of fun to kick around, to discuss, but we need to be careful that it doesn't push the sector in directions that don't ultimately benefit what the end users are looking for.
I feel like
Yeah.
Worley is typing on his keyboard to have his OpenClaw create a Q Linpack just to taunt you with it by the end of the session. But
You can spell Linpack with a Q. You don't need to.
all right. Okay. So
But Jay, I just want to jump in for a second as a shameless plug for Metric, which is Unitary Foundation's open framework for community-driven benchmarking, because I think Bob's making a really good point, and the way to sort of reduce that risk of a totally useless but aesthetically pleasing benchmark is for the community itself to work on what should we be measuring and how, because then it can be tied to tangible value.
Yeah, and I will second that. I think that is a really important part. As Sebastian knows, and I think Jay, I started the IEEE Quantum Computing Standards Working Group in 2016, and none of the providers.
A little too early.
Well, and it's going now, and still very few of the hardware providers want to participate. And I think a community-based standard like what Unitary Fund is doing with Metric is absolutely the way to go.
If I could just
by the
jump
way,
in,
Sebastian, I did tell Worley that back then too. I said,
My
little too
definition-
early.
my definition of a perfect metric or standard is one that every vendor hates equally, but each for a vastly different reason.
Yeah.
This way, they all feel like they're being denigrated
Yes.
in some way.
Yes.
So that's what everybody's equally unhappy.
Yeah,
You know, you've
equally
got-
unfair to everyone.
Yeah.
exactly.
All right. I'm going to move on to question 3 here, because this one has really been on my mind a lot in 2026 as I've been to supercomputing conferences in Asia and in Europe. I've seen a lot of work on hybrid classical quantum computing. There are researchers that are getting access to quantum systems and exploring algorithms now, trying to find scientific value, as Bob was just getting at, and Worley as well, trying to find real value out of these systems, even if they're small, even if they're noisy. Can they, in concert with a classical HPC system, provide some scientific value now, and or can they be used to set up for scientific success very soon? How do you feel about the early efforts in hybrid classical quantum computing? Do you feel it's too early? Do you feel that now is the right time? Do you feel it's not only the right time, but you're seeing some interesting results that you think are exciting and more people should be looking at this now, at least in research communities, if not enterprise, maybe enterprise also? Where are you on the hybrid classical quantum explorations going on right now worldwide?
Well, I mean, maybe too early again, because this is what we've been doing for most of our customers for quite a few years now. I mean, the quantum systems aren't necessarily ready for production and prime time, but that doesn't mean they're not useful. Sebastian brought up a really good point earlier, which is that you have to separate, the scientific progress from the actual business implications, because when we see a press release, as he said, there's truth in all of these. Hey, we think it did this, or we achieved this new thing, or we moved an atom this many nanometers apart. It all is true, and in science, I read those, it's like fascinating, but those get represented in the business press as like, quantum's going to kill all encryption. No, it's just asymmetric, right? Quantum's going to do this, and so I think that's important. I think what we looked at early on was, how do we use the HPC systems and the quantum systems to offset each other? And so sometimes that's using HPC systems to reduce the amount of data and stuff to a subset that we can then synthesize and put on a quantum machine and run on however many qubits we're limited to. Sometimes that's in using stuff that we have on the quantum machine and expanding it out and then running big stuff. So, you look at large energy companies and things like unit commitment problems, or you look at pharmaceutical companies and things like peptide design and discovery and stuff. And we've had great success with this. And as Sebastian has said for years, I know Bob has said this too, I think all three of us have said, quantum's not going to replace everything necessarily, right? It's going to be this new augmentation of the compute we have. And so I think you're talking to 3 people who, I don't want to put words in their mouth, I want to hear what they have to say, but I think we all agree that that's something, everyone should be doing. And I think you're seeing that even with companies like D-Wave, right? Their hybrid unit, I mean, that's what it does. You're seeing IonQ do this, you're seeing Quantinuum do this, and so and Google and what Hartman, they've done this, right? And so I think this is just the reality of where we are today. And I think a few companies have been there for a couple of years. I'm glad it's catching fire. It's the first time when we were in Germany together, Jay, that I saw it at a HPC conference, 2 years ago. But I think that's exactly where companies should be looking at is, don't try to do this thing where you're like, economics don't work because I can't replace all this HPC with this quantum. Figure out how you can improve it, what you can augment with it, where you can get an advantage by using them together.
All right, Bob, Sebastian, you want to chip in on the hybrid question, the state now
Go ahead,
and
Bob.
prospects?
Yeah, I gotta, first we need to define some terms here. I find a lot of organizations, especially in the quantum side, they think of hybrid, and the example is, I'll talk to companies and I'll ask them what their main applications are. Sometimes they'll say, well, the main application we have for a hybrid is error correction. And I'm like, no, you don't tell a customer that they're going to need an HPC to make sure that their quantum system runs right. That's not an application, that's overhead. So you need to talk about what hybrid really is. And to my mind, and for the people who are familiar with code out there, there's two types of hybrid that I think work. The first one is if the quantum system is a systems call. I package up a request, I send it to it, and it goes off and does its thing. And it comes back with an answer and I keep going. Then the other one is if it's embedded in a do loop. Is it something that is so innately iterative that the two machines need to be entirely in sync with each other? From what I'm reading, and I'm no expert in algorithmic design at this point, but the idea is that the need for the nested do loop kinds of applications are not proceeding as fast as the system call applications. And we've seen this before. This is when you used to buy a Cray, you only threw jobs at the Cray that were vector oriented. You didn't try to make it part of your overall compute architecture. You said, if it runs long vectors, we're there. If it doesn't, we're not going towards that machine. And when it did, you threw a programmatic or a systems call to it. And I think that's what we're going to see in quantum for a long time, unless there are some very interesting algorithms that can really take advantage of the do loop phenomena. But I haven't heard a lot about them. So to me, the hybridization process is still taking advantage of classical when it's classical and quantum when it's quantum. And don't try to force this idea of they have to be intimately associated all the time for it to be effective. And the other thing is for the earlier comment about error correction, I see a stage where ultimately error correction becomes so subsumed in the quantum computing architecture that the classical world will have no idea what's going on under the hood when it comes to error correction. And that will move away this idea of hybrid. I need a supercomputer to run my quantum system. Just to me, it's all about defining your terms here more than anything else.
I totally agree, Bob. I mean, especially the quantum error correction, it obviously is going to be in the box, and you won't be thinking about it being a hybrid use case. Although at this stage in research, that is necessary. I do worry about the emphasis on the tightly coupled kind of use cases, which really aren't emerging as a way to drive sales of on-prem boxes, which are black boxes. So they don't really have any research value being on-prem because you can't crack it open and mess around with the inside because of IP. And so it might as well be in the cloud. And that's, I think that's the stage we're at, is that it's really interesting seeing all of the more asynchronous or system call, to use your terminology, use cases starting to emerge. There's been some really interesting work in the last year or two that's starting to get really promising, but none of it that I see is requiring that sort of same rack or same room kind of latency times.
All right, I'm going to try to, with this next question, wrap up the different things we've talked about here, the progress in different modalities, the defining success, not in terms of number of qubits, but in terms of mapping to a workload, the integration of classical as appropriate to solve the overall problem. And let's talk about good enough quantum. Are we close to an era of good enough quantum? I know that none of you would say, we have perfect quantum systems, because we don't. But are we getting close to, you expect in late 2026, 2027 to see an increasing number of papers demonstrating, like what Bob said a little while ago, about a 30% increase in performance in that financial application? Do you think we're going to see good enough quantum in second half this year, early half of next year, that demonstrates that classical plus noisy small quantum equals win still? And maybe each give an example of something that you've seen that you think already demonstrates that or is on the verge of it. And Bob, I'm going to go back to you on this. I know as an analyst, you're looking across the entire landscape at all times. Why don't you start with this one?
Yeah, I think good enough. First of all, don't forget, we'd have a lot of good enough in classical. If you want to go down an interesting rabbit hole, look at all the simplifying assumptions that go into calculating the low energy state of a molecular structure. All the things that we just say, okay, ignore this, pretend this, it's a point mass, it's this. It's an incredible thing to see how many shortcuts that we take in the classical world simply because the answer kind of works. And so that's the first thing. So the other thing is, quantum is good enough in a way that, and I like to use optimization problems as an example. Optimization has been around for a lot of years. There's not a lot of new ways to optimize a process. But if a quantum system can actually do just a little bit better, it may not give you the ultimate solution to a traveling salesman problem. It may not give you the absolute purest theoretical solution. But if it gives you a 2% better solution than a classical counterpart, and perhaps in real time, or at least near real time, and again, if that scales, if you are now rerouting, if FedEx or Amazon is rerouting all their trucks real time based on traffic patterns, trucks breaking down, accidents, drivers not showing up, if you can get that at a 2 or 3% advantage, that's just good enough. But if that scales again across all your trucks every day, across your global distribution network, that 2% translates to some significant economic return. So, take time to really understand the impact of what quantum is capable of doing, as opposed to holding it to a standard that in some sense is beyond the standard that in many cases we hold the classical world to. My favorite example, Gaussian elimination with partial pivoting, theoretically unstable. No theorist would ever use it, but everybody uses it because it works. And I think we should give quantum a little bit of that leeway as well.
And so, Bob, I appreciated that background, but now I'm going to ask the question again on good enough quantum and examples right now where you're seeing that.
My favorite one, because it's just so cool, is D-Wave has this thing with one of the ports in Los Angeles where the ships come in and they're container ships. They have to be unloaded, and they get unloaded and they're put in stacks because eventually a truck will come up and they'll load the container onto the truck. Now there's an optimization problem. Ship comes in, we'll stack these containers on all these different things. We only have so many cranes to take it off the ship. We only have so many different cranes to put it on the truck. We can come up with an optimal solution until one truck breaks down, and then the whole thing falls apart. So classically intractable. What D-Wave is doing right now with those folks is uploading a status report every 15 minutes about the current state of containers, trucks, and ships, and all the combinations. And D-Wave sends back an optimal solution within the time frame. So they're doing this at a significant near real-time optimization algorithm to allow for the fact that ships don't show on time, containers can't be found, trucks break down, all the other things. It's a near real-time solution that is intractable classically within the time frame. And they have statistics that show the increased efficiency of getting containers in and out of the port, minimizing movement, using less cranes, making sure trucks don't have to stand in line for long periods of time. It's a wonderful example of an incremental improvement of near real-time optimization. Is it the perfect solution? No. Does anybody at Port of Los Angeles care that it's not perfect? Not right now.
Great example. Worley, Sebastian.
Okay. I mean, I agree with Bob that there are incremental improvements coming from, I think QPU's doing some really interesting work, for example, where they're doing quantum derived sort of seed for a classical machine learning model and getting slight efficiencies. And if the problem is sufficiently large, then even a single digit improvement over the existing methods it can be good enough, right? There's the argument about theoretically provable advantage is really comes out of computational complexity theory, comes out of quantum information theory. It's going back to the dichotomy of like the progress on the scientific front and the progress on the business front. They're both really necessary, and they're almost apples and oranges. I mean, one of my another touch point of like classical computing history is the invention of the Monte Carlo algorithm, Stan Ulam at Princeton. That was a heuristic to be able to do better neutron diffusion calculations, and it wasn't until 30 years later that somebody applied it to a financial portfolio. So I watch really closely what the scientists are doing to sort of scratch their itches on these devices, in large part because I think those are early indicators of where good enough will become better and better and better. There'll be emergent applications out of those techniques that are developed on the scientific frontiers.
Great. And Worley, I know you have some thoughts on this because you've worked with so many customers in this space now.
Yeah, these are great points. I think the thing to remember is the industry is focused on this broad, quantum does it, it's done it. And the reality when you get to the good enough is it won't be across everything. It'll be like Sebastian said, somebody will take something that was done for neutron diffusion and put it in the finance, and like this will work. And the D-Wave work is very credible. There's a lot of work we've done with them for customers as well. There's a ton of whether it's BP or J&J or Anduril or whoever, there's a lot of customers who are looking at this from this good enough lens. When I talk to customers now, this is their focus, which is just like, again, price, performance, return on investment. But they're not coming to me where 3 years ago they were like, how does this change the whole world? I've read all this stuff online. Now they're saying, okay, what could be the advantage? What could be my quantum advantage, right? Where's my alpha in using quantum and deploying it in a very specific area? And I'm looking for, we've talked about several examples, but there are industries where a 1-2 single-digit % change is billions or tens of billions of dollars in results. So I think, fortunately, I'm seeing customers move to the good enough. I'd like to see the industry move there as well, and grow at the pace. I feel like the way funding has happened, the way some of the stock market insanity has happened, we've skipped a bunch of steps in what should be the natural progression, where we go, hey, we're just going to prove it out a little bit at a time. It's going to take another 5 or 6 years, and then we'll get to this big thing we're talking about some point in the future, which, by the way, is always hindsight, right? The one thing that bugs me is we as humans are horrible at predicting the future of any technology. I mean, there were protests, there were signs in the Old West that were like, don't bring electricity to your town, it'll burn everyone to death. So like we're not, when I hear everybody making their predictions of when this will happen, it's like, we're horrible at that. I mean,
you saw what it did to that elephant.
Right. Yeah, exactly. That's a great AC/DC, right? So it's there's so many of these arguments that I think, why don't we just focus on the good enough, like you're saying, on what can be done right now? And it doesn't matter, because if it's not good enough for Sebastian or Bob or you, Jay, but I get a 6% improvement that results in $1.5 billion, I don't really care, right? That sounds amazing. Yep. How do I buy more of that?
Hey, Jay, can I just interrupt again one more time? One of the interesting things I saw, this good enough idea, is there was a blog put out by Rolls-Royce. Rolls-Royce that makes jet engines. They don't do the cars anymore. They sold off. Have been looking at quantum for almost the last 8 or 9 years, and they released a blog a couple months ago that says they have been dabbling in using quantum to do computational fluid dynamics, linear solvers and such. And what was interesting is when they coded the thing up, they said that the results they got were better than what a classical quantum analytical output would predict. And they said they were really surprised at this, and they're trying to figure out exactly, what is different from the practical versus the theoretical. So maybe we're not moving from good enough to better than expected for certain applications. And as quantum capabilities get into the hands of end users and they start playing and they start doing all the things that the HPC world has done forever, heuristics, shortcuts, tricks, ways to solve a problem that may not be theoretically stable, but just works because it works, I think we're going to see more and more of better than expected than good enoughs.
All right. I'm going to wrap this up with a final question. It does have 3 parts to it as well, or 3 recommendations. Really, I want you to get to what your top recommendation, your top concise recommendation would be for quantum computing vendors, for companies and organizations that may need quantum computing at some point, and for this audience, for the professionals in this audience that are thinking about exploring quantum computing for their research, for their careers, et cetera. So again, top recommendation for the quantum computing industry, for the customer industry of quantum computing, and for the individuals on this call and elsewhere that are thinking about beginning their quantum journey. And in keeping with the previous 4 questions, is it the right time? I think I know what you're going to say to that for all 3 groups, but be honest about your assessment of the timing of these recommendations for all 3 of these. Bob, I want to start with you. Top recommendation for vendors, for customer and government agencies using the results of these vendors' work, and for the individuals on this section.
For vendors, it's easy. Stop fighting with each other. Stop coming out with metrics that nobody understands or can translate into performance gains just to prove that you're better than the other guy. I've got my roadmap. He's got his roadmap. By the way, look at this. Look at our gate fidelities. Look at our error correction ratios. No one gets those things. Remember who your customers are. You're not competing with other companies. You're trying to inform end users about what your capabilities are. Make your messaging clear. And I think end users should start to demand that. Don't walk in the room and be shy when they start bringing out these graphics that you have no idea what's going on. Say, what does this mean for? I was talking to a company a couple of weeks ago, and I said, you have to understand vertical specific languages. And I said, so like if you walk into an oil and gas company, you better know exactly what your system could do for seismic imaging. And one of the guys in the room raised his hand and said, what exactly is seismic imaging? And I said, that's the question you ask that ends the meeting, because that's 80% of oil and gas computational requirements are seismic imaging. If you can't answer those questions of the end users, and if the end user can't get their questions answers, walk out, end the meeting. Don't pretend that you know exactly the difference between Clifford and non-Clifford gates. That doesn't translate to any kind of intelligent decision.
All right, that was for the industry. What about the end users, the companies?
The end users, they need to understand what their key performance indicators are, what really matters to them. And for God's sakes, it's not system utilization anymore. It's your most expensive asset, your scientists, your engineers, your innovators, having access to the machines they need. Don't you have, I remember talking to a company, they were very proud, their HPC had 98% utilization. I asked them what their average QA time was. They said 13 hours. I said, so you've got a lot of really smart people sitting around waiting for their job to run. You have a misplaced sense of guidance when it comes to KPIs. Come up with the KPIs that matter to you and make sure that the quantum system you're looking at fits into what matters most to you. Is it innovation? Is it utilization? Is it job turnaround time? Whatever it may be, decide what matters to you most and insist that the systems you look at can meet those KPIs. Because they won't be consistent.
Bob, thank you for those great recommendations for all 3 of those sectors. I'm going to ask Worley and Sebastian for concise responses to each of those 3 as well. We've got a question or 2 I want to try to get to. We may not get to it, and apologies if we don't, but Worley, recommendations for quantum computing sector, the customers and agencies that need to use it, and people on this call that may want to begin quantum journeys.
Look, focus on outcomes, right? For most enterprises, right now, it should be about being ready for this, not some procurement theater. I mean, start with problems that are intrinsically quantum or have well understood mathematical structure. Don't start by taking every difficult classical problem and adding the word quantum and trying to shove it in there, right? Which is happening from both vendors and users, right? But listen, it's about outcomes, period. And those outcomes have to be seen through the lens and the perspective of the end user that's paying for this quantum access, right? And so focus on outcomes and talk to everybody. Like every vendor you talk to is going to throw the other vendor under the bus. Don't read a press release and be like, oh, I read this today, I'm going to go call them. I talk to so many customers that see a press release, call that company, get pulled into the cycle, and there's 20 other options. Some are cheaper, some are better, some are whatever. talk to as many people as you can, gather as much data as you can about what's available out there. But again, for both vendors and customers, focus on the outcome of the user of the product, right? Period.
And for the audience?
Sorry, for the audience, look, the same thing. Go look at all of them. Take everything with a grain of salt. Go look at all of it. Read as much as you can. Go to things like this as much as you can. All the vendors are doing, webinars like this. Everybody's doing it, and learn as much as you can. But come up with your way of, what do you want to get out of quantum? Is it a career move for you? Is it something you want to use in your business, et cetera? And then, set up some criteria for what you want to do and evaluating all of that, because it's super hard to evaluate. I mean, Bob said it best. A lot of these vendors walk in and there's like science, physics, math, and the CIO is like, I have no idea what you're doing. I mean, the funniest thing that happens is, no matter who I give, I'm in a meeting with the CIO, I give them the Quantum Computing for Dummies book, and they're like, whew, this could be a little above my pay grade. And you give them the baby's book and you're like, that's it. And it's like, you have to be able as a vendor and as the audience and as a user to break these things down into these much more simple constructs. And that's super difficult with quantum.
And
I'll be really concise. Vendors focus on shipping logical qubits, number one, that actually work. And that meet the roadmap. Customers, two things. I mean, I think Bob's point about the vendors seem to be competing with one another. It's almost like we're in the phase where they're thinking like Thomas J. Watson. Like, I think there's a market for maybe 5 computers, right? So they're kind of competing on how many on-prem quantum computers are going to sell before everyone realizes they don't need an on-prem quantum computer. So watch out for that sales pitch. And, I mean, with logical qubits or anything else, ask how they're defining that thing, right? I mean, because back to the metrics point, no 2 vendors are going to have the same logical qubits. So ultimately it comes down to what's the practical performance you get out of the box. And for the audience or anybody exploring quantum, I'll do another shameless plug for Unitary Foundation. I love the Unitary Foundation in part because it creates a whole bunch of entry points for classical developers, web developers, full stack developers, whatever kind of developers, to get involved in open source communities around quantum projects, and with no prior training, suddenly turn into experts. The greatest story from Unitary Foundation is Misty Wall, who was a EE from ASML, pitched in to fix some bugs in MITIC, the error mitigation framework that Unitary Foundation maintains, and had no background in quantum physics. She was a guest on the podcast, that's why I know this story. And then 2 years later, she's a lead author on an error mitigation research paper on the archive. And that's the best on-ramp I think exists in the industry.
That is a great ending story, Sebastian. We have time for one question, but let's give our speakers a round of applause first. Thank you guys for answering those questions, enlightening our audience. I learned a lot from you guys as well today. I'm going to ask one question. I think we have time for one here. We usually measure computing progress in performance, but should quantum advantage instead be measured by something like cost per solution, energy per solution, or problems that were previously economically impossible? I'm going to ask you, you've all kind of addressed this, your quick response to that question. Start with Worley.
I mean, I think we should drop the whole quantum advantage cost stuff completely. I've said this forever. I'm so sick of it. It's a desperate, just like all the security talk, it's a desperate attempt to try to rise one technology in your company above everybody else in a world where you're going to have to work together anyway. So I think for me, again, it's only about the outcomes. The energy use, yay, who cares? All of these things are such minor fractions. I want to see everything be about the outcome. I spent this, I did this, I got this outcome, and this was a return on investment. It has to be the measure for us to build an industry.
All right, Bob.
2 things. First is quantum should not be viewed as a standalone. It should be part of the whole food chain, from an innovative idea in a research facility all the way to productization. And how it fits into that food chain is how its value should be determined, not this quantum system does this and this quantum system does that. Second of all, just a quick diversion. Jay, I was told you'd be giving out an award for best graybeard on the panel today, and I haven't heard anything about that yet. So, feel free to.
You all can all come over and pick from this shelf over here. I'll give first,
Okay.
second, and third place.
All right, sounds good.
Or books, either one. Yeah. All right. Thank you guys so much for answering those
We
questions.
didn't hear from our third panelist here.
Oh, sorry.
I mean, I agree, unsurprisingly, with both of the prior statements. I think, the only thing I would add is, and this goes for technologies and maybe economic activity as a whole, I think we need to do a better job of measuring externalities, because if you just say, like, what did I spend and what did I get, you can be omitting a lot of hidden costs. And that could be energy consumption or environmental or sustainable or social costs. And I think, technology as a whole has a lot to work on in terms of making sure that we are accounting for externalities and counting true costs.
Great. Thank you guys again for that. Really appreciate it.